Imagine a time before everything. No Earth, no stars, no galaxies, no space, no time. For all of history, humanity has looked up at the night sky and wondered where it all began. The answer takes us back 13.8 billion years to a moment when the entire universe was smaller than a single atom. Then, in a single instant, everything changed. This moment is known as the Big Bang. And in the first few seconds after it happened, the foundations of the universe were created. The Big Bang was not an explosion in space. It was the creation of space itself. Before that moment, there was no universe waiting to explode into. Space, time, matter, and energy all began together in one unimaginable event. In the first fraction of a second, the universe expanded at an incredible speed, faster than light. This phase is known as cosmic inflation. For a brief moment, the universe expanded so rapidly that distances between regions of space grew faster than light could travel. This sudden expansion smoothed out the cosmos and stretched tiny fluctuations in energy across unimaginable distances. Those tiny variations would later become the seeds of galaxies, clusters of stars, and the immense structures we see in the universe today. Within an instant, the universe grew from something smaller than an atom to something far larger than entire galaxies would eventually become. But the universe was not calm. It was a violent, searing ocean of pure energy. Temperatures were trillions of degrees. Nothing like stars, planets, or atoms could exist yet. As the universe expanded, it also began to cool. In those first seconds, the energy filling the cosmos began transforming into the first particles of matter. Tiny building blocks that would eventually form everything we know. Particles called quarks appeared first. They quickly combined to form protons and neutrons, the components of atomic nuclei. This happened incredibly fast. Within the first second of the universe's existence, the fundamental ingredients of matter were already forming. But something strange also happened. For every particle of matter created, a particle of antimatter also appeared. When matter and antimatter meet, they destroy each other. Yet somehow, a tiny imbalance remained. A small fraction of matter survived. Scientists still wonder why this imbalance between matter and antimatter existed at all. If the universe had produced perfectly equal amounts of both, every particle would have collided with its opposite and vanished in flashes of energy. The universe would have been left empty, filled only with radiation. The fact that matter survived, even by the smallest margin, made the existence of galaxies, planets, and life itself possible. That tiny leftover amount would eventually become every galaxy, every star, every planet, and every living thing. The idea that the entire universe began from a single moment is almost impossible to imagine. So here's a question for you. What do you think the universe looked like in those very first moments? Share your thoughts in the comments below. It's always fascinating to hear how different people imagine the beginning of everything. Within the first few minutes after the Big Bang, protons and neutrons began combining. They formed the first atomic nuclei, mostly hydrogen, some helium, and trace amounts of lithium. These simple elements would become the raw material of the cosmos. But something was still missing. Electrons could not yet attach to these nuclei. The universe was still far too hot. For hundreds of thousands of years, the universe remained a glowing plasma of particles and radiation. A bright fog filled with energy. light itself could not travel freely through it. Then, about 380,000 years after the Big Bang, the universe cooled enough for electrons to finally join atomic nuclei. Atoms were born, and suddenly, light was able to travel freely through space. This ancient light still exists today. Astronomers call it the cosmic microwave background. It is the oldest light we can observe, a faint glow that fills the entire universe, a snapshot of the moment when the cosmos first became transparent. It is, in a sense, the afterglow of creation. After that moment, the universe entered a long period of darkness. No stars yet existed. Only vast clouds of hydrogen and helium drifting through space. Slowly, gravity began pulling these clouds together. Over millions of years, the gas became denser and hotter. Eventually, the pressure became so intense that nuclear fusion began. The first stars ignited. These early stars were enormous, many times larger than our Sun. Inside their fiery cores, they forged new elements: carbon, oxygen, iron, elements that did not exist before. When these stars eventually died in violent explosions known as supernovae, those elements were scattered across the universe. They would later form new stars and new worlds. As more stars formed, gravity began organizing them into vast structures. Clusters of stars gathered together. These clusters became the first galaxies. Across billions of years, galaxies collided, merged, and evolved. One of those galaxies would become our home, a spiral galaxy known as the Milky Way. And if you're watching this video right now, tell us in the comments where in the world you're watching from. It's always amazing to see how curiosity about the universe connects people across the planet. About 4.6 billion years ago, in a quiet region of the Milky Way, a new star began to form. Around it, a disk of dust and gas slowly gathered. From that swirling cloud, small rocky worlds began to appear. One of them would eventually become a small blue planet, a planet that would one day hold oceans, life, and us. That planet is Earth. If you enjoyed exploring the beginning of the universe, consider subscribing to the World Chronicle. In the next episode, we'll explore how our solar system formed and how the Earth was born. And if you enjoyed this journey to the beginning of time, don't forget to like the video. It helps the channel reach more curious minds around the world.